We're going to start with a real life situation so you can understand what we're doing. You earn $12 per hour at your job. I'm not sure. Have they changed the minimum wage? No. Oh, well. Or is it supposed to go up on January 1st? I don't know. It goes up. It goes up. Anyway, for right now, it's 12. You earn $12 per hour at your job. How much do you earn for working 40 hours? What am I going to type in the calculator to figure? Now, you guys understand that it wouldn't actually be that right because of what? Like that won't be what you actually end up because taxes are going to come out. But just for the sake of going over this, that's, what it would be. So $480. How much do you earn for working 35 hours? Well, what am I going to type in for that?
12 times 5.
Perfect. $420 cash money. Now this one is backwards. It says how many hours did you work if you earned 456? What am I going to type in now? Instead of multiplying, you're going to divide by 12. So 38 hours. Good. And then the last one, how many hours did you work if you earned 384? So I'm going to do 384 divided by 12. Oops. Oh, close. 32. Being able to estimate is an important skill though. So I like when people make a guess before I type it in the calculator because you want to have some common sense as well. So graph a representation of this. If you work 0 hours, how much money did you make approximately? 0. So you can start there at the origin and then you don't really need to plot all these points, maybe just a couple of them. What was 40? For 40 hours, what did we get? 480. So do you see how 40 here on the x-axis gives me 480? That's like practically off the grid. So like a point there. Here's the trick is that you just make the points larger. That's what I always do. You make your points bigger, then they'll all connect. And then let's maybe do one more. 35 hours. So 35 on your x-axis gave you 420. That would maybe be like right about there. But you can connect them. It's going to look something like this. Well, do your best. Okay. It doesn't need to be perfect. Good enough. Good enough. Now, what the lesson is about is slope. So here's the million-dollar question here. What is the slope of that line? And it's in the question if you go back and read. Yeah, what is the slope of that line? Like how much is it going up by? Why is it 12? It is per hour. Anytime you talk about a slope, listen, the word per should be in there. It's something per something else. In this case, it's dollars per hour. Okay. Here are the types of slope. This one is positive. Why do you think that's positive? Going up. Use your common sense. It's not that hard. All right. This one is negative. I don't know what that is, like a little penguin on a ski slope. Negative. Go. Do you ski? No. No. Oh, that's cool. All right. This one, the flat one, is 0. It's not going up or down at all. So it's literally nothing. So 0. And then this vertical one is what we call undefined. UNDEFINED, or you can write UND for an abbreviation, but undefined. That's a slope that you could not walk up. You would need like suction cups on your shoes, or you would need to like be a spider or something. Spider-Man. Or Spider-Man. I don't know enough about them to understand it, but here's a little acronym to help you remember it. Shh. You guys can stay quiet and focus. I'll give you a halfway break, but you need to look and you need to listen. An acronym is not a word. It's just a way to help you remember things. So here's the acronym for this. It is HOI VUX. I know that's not a word. It's just a memory device. All right. H stands for horizontal, which is this way. Horizontal is like the horizon. Horizontal. Or like the line in the H. Remember it that way? Horizontal. Now the O stands for 0. It means 0 slope. It's not an O like the letter O. It's a 0. Okay. Horizontal lines have a 0 slope. And when you write their equation, it is y equals whatever the number is. So can you give me a single digit number and we'll make one two. Perfect. Let me zoom way in. Shh. Watch and listen. I'm going to draw in my line horizontally at 2. Do you see how I did that? I counted 2, 1, 2, and I drew that in. That's the line y equals 2. It could be y equals 17 or y equals 45. Please don't do that. Those belong to me and I spent my money on them. Thank you. It could be y equals -4, y equals whatever. You would just draw the line there instead. Do you understand? Like y equals 7 would be up here. You get it? Cool. I'm going to take your silence as a yes.
Yes.
Okay, good. It's not that hard, right? All right. Now, the other way, what do you think? V stands for vertical.
Undefined.
And that does stand for undefined. And it's x equals something. All right. So vertical lines, which is this way, have an undefined slope. Remember the little penguin that was like eek? All right. And they are x equals. So give me another, not 2, let's make it different, but a single digit number. Let's do 5. So if you do x equals 5, what you're going to do is count 1, 2, 3, 4, 5 and draw a vertical line. You'll be okay. I'm not going to take off points for like your art skills. Okay. Like it's all right. Now we're going to do a little bit more. And if you guys are focused, I'll give you a halfway break, but I want to finish like the next little section here. So find the slope of a graph. All you're going to do is count the little boxes. I'm going to use a little marker to draw these in here. You need to look because I don't have a better explanation than, hey, look it. Do you see how this point right here is on a nice, pretty point? Like it's on an exact number there. This one. Do you see? Okay. Like I call them pretty points. And then do you see how this one is also on a nice, pretty point? Like it's on an exact. Okay. So what we do is we call this rise over run. It's how much up and then how much over. So I'm going to draw in the little triangle. And all you have to do is count how much up and how much over. So how much up does this go? Let's see. 1, 2, 3, 4, 5, 7 is what I count. Up 7, over 4. And so your answer is 7 over 4. Good job. Now, if it reduces, like if the fraction reduces, then you would have to do that. Let's just try it again. You want to find nice, pretty points. Now, they are kind of highlighted for you. Do you see how there's one here and one here? Well, but you can't count. I get what you're saying. Don't discriminate against the non-pretty points, but you need to be able to count the little boxes. Now, this one goes down. So what do you think that tells us about the slope? Good job. Negative. So we're going down. What is it? 3, 4, 5, 6, 7, over 9. Now look, it's -3 over 9, but that fraction reduces. Does anyone know how to reduce? Good. -1/3. Can you guys focus back there for me? Just for a little bit longer, all right? We'll finish this page. Can I show you something in the calculator real quick? Can you guys look? You guys are doing better with that. So how do I share my screen here? Share my screen. Share. So this ends up on the recording. Watch this. If you type -3/9, do you see this handy little blue fraction button off to the side here? If you hit that, it'll reduce the fraction for you. So if you ever don't know how to reduce a fraction, you can always type it in the calculator. The calculator will do a lot for you. All right, let's find some pretty points for this one. I see one right here and one right there. They were kind of highlighted for you. You guys focus for a little bit more for me. You have to look and listen. All right, how much up? 5 and then over 3. Good. So your answer is 5 over 3. Does that reduce? It does not.
No, because it's odd.
Okay, we'll finish these two here. Now you're going to have to graph the line yourself. Are you okay back there? Just dropping things? Okay, well, be careful. So the first thing you're going to do is plot the point. Do you see, you have to look. Do you see this point here? -3, comma, -1. So on your x-axis, you would go -3, and then on your y-axis, you go -1. So that point would be right there. So that's your starting point, -3, comma, -1. I'll show you this on the calculator too. Look it. If you ever don't know where a point goes, watch this. Parentheses, -3, comma, -1. Do you see how I put the point right there for me? If you ever aren't sure, type it in. It'll show you where it goes. Now it says a slope of 2. When it's a whole number, that does confuse people. Oh, good job. If you put it over 1, it's up 2 over 1. So watch, from this point, you're going to go up 2 over 1, up 2 over 1, up 2 over 1. Now, I usually get asked, hey, Ms. Cole, how many points do I have to show? And here's my answer. All of them. Go until it won't fit anymore. And if you feel like complaining about that, if you can count to 2, you can do it. Okay, so I don't want any complaining about that. How many points do you want to show? All of them. It's not that many. Get on board. I'm not asking for a whole lot from you there, okay? It's not that hard. Good job. And then you won't be like, I can't draw a straight line, because if you have all the points there, it'll be easier. All right, 6, comma 5. That's going to be 6 for the x direction. So 1, 2, 3, 4, 5, 6, and then 5 for y. So right there, 6, comma 5. And if you didn't know where it went, you could type it in Desmos. It'll show you right where it goes. Yes, it's 6 to the right, 6 for x, and then 5 for y, so up 5. So from the center, you go right 6, up 5. Now this slope is -2/3. So from that point, you're going to go down 2 and then over 3. Now look, if I try to go down 2 over 3 again, I'm going to be off the grid. But allow your instinct to kick in. It should be a straight line. So the other thing you can do is go up 2 and then left 3. So up 2 and then left 3. Just do as many as will fit. Now, what else tells us that we did the negative slope correctly? Like, what about this means negative? It's going down, right? All right, I hit record. We're going to keep on going. So we're going to plot the point 4, comma 3. So you're going to go 4 in the x direction. 1, 2, 3, 4. And then 3 in the y direction. So it should be right there. Again, if you ever get stuck or you're on a quiz or test, you're just not sure, or if you want to check, just type the point in Desmos. It'll show you where it goes. Shush. We need to look and we need to listen. You need to look up here to see what's going on. You need to listen to me, so I don't have to say everything. Group in the back. I'm looking at you. Look and listen. Now it says slope of 0. So what kind of a line is that going to be?
No, it's going to be a line.
Well, all lines are straight. Horizontal. Horizontal is what I was looking for there. Zero slope is horizontal. Hoi. Horizontal, 0 slope, it would be y equals. Yeah, that's your little acronym there. You guys need to be respectful. All right, so to plot the point -2, comma 6, you're going to go -2 for x, +6 for y. So that'll be right there. Good, and undefined means vertical. So here's your point. Then you're going to draw a vertical line going through that point. Good job. Y'all got that?
Good job. I got it.
Just remember, you guys are close enough to the microphone that it's picking you up on the recording, okay?
Okay, microphone.
Okay. Now, moving on. Tired of having to shush you guys. How could you get the slope without a graph? So say you didn't have a graph to look at. What you would do is you would pick 2 points. You're not going to have to pick them. They're going to be given to you. And here's your slope formula. It's y2 minus y1 divided by, good, x2 minus x1. You've done this before. You subtract y, fraction bar, you subtract x. The only thing is remembering which one is which. Okay, so listen to me and I will explain it to you. For these points right here, every point is xy. So this is going to be x1, y1. That's your first point, the first point. So those get ones. And then x2, y2, I wrote a little bit too big labeling them, but that's your second point. And then you just plug them in the formula. So you are going to subtract the y values. It's going to be 4 minus 7. Hey, Miss Cole, what if I wanted to do 7 minus 4? That's actually okay, as long as when you do the denominator, you do it the same way. Okay? I like to do x2 minus x1, though, just because that's what the formula says. So it's going to be negative 6 minus, now I want to see if you guys understand this. When you do minus negative 4, it will be plus 4. But if you guys aren't sure, you can write it this way, minus negative 4. Are you all looking and listening? Now here's what I'm going to do. I'm going to go over to my Desmos calculator. Let me share my screen. Oh, wait, question. Go ahead. Hold on, was there a question? No, you want to do the y values on the top and the x values on the bottom. So y's go on top, x's go on bottom.
But what is it now?
It doesn't matter which order. So if you wanted to do it the other way around, if you wanted to do it this way, 7 minus 4 over negative 4 minus negative 6. Oh, because there's two fours. I see what you're saying. These are both fine, though. So whichever way you wanted to do it is okay. That's a good question. I would love for everyone to listen. Shh, guys. The reason how come the y's go on the top and the x's go on the bottom is whenever we're doing our slope. Do you see how we did the rise part over the run? So it's the y change over the x change. Are you guys? All right. So what I'm going to do is share my screen. And again, it doesn't matter which way you write this. Let me share my screen so we can go to the calculator. And I'm going to type it exactly like it looks. 4 minus 7 divided by, what was it? Negative 6 minus parentheses negative 4. What's my answer? 1.5. Now, what if I wanted that as a fraction, not a decimal? Do you see this handy blue fraction bar? Look at that. 3 over 2 is your answer. So 3 halves is your answer. You just type in the calculator. Now, to check your work, if you plot those points, it should make sense that you go up 3 over 2, up 3 over 2. So plot those points, negative 4, 7. Negative 4, 7 would be right here. Negative 6, 4 would be right here. And do you see how when you connect them, it goes up 3 over 2? Like, do you see it? Yeah. You have to look. Yeah. Heck yeah. I love it. I like the enthusiasm. Wait, how much did we do? Oh, 3. It went up 3 and then over 2. Because it was 3 over 2. So up 3 over 2. Hey, we're going to try it again. Look, these are your x's and your y's. x1, y1, x2, y2. If you don't want to label those, if you're like, Miss Cole, I know the difference between X and Y, that's fine. I'm trying to teach the material to an entire class full of people. And, if it helps you, then write it. So you're going to use your Y numbers first. Which two are your Y numbers? Good. So it's going to be 5 minus 3. 5 minus 3 over 4 minus negative 2. You just subtract the y's, subtract the x's. Good job, guys. I didn't have to say anything to you recently, so that's awesome. Now I'm going to share my screen. Are you looking? It's a look. All right, 12. That's a personal choice. All right, 5 minus 3 over 4 minus negative 2. See that? 1/3. So 1/3 is your answer. And when you plot these points, that should make sense that you're going up 1 over 3. Stop talking while I'm talking. You guys are going to get separated if you can't pay attention. All right, negative 2, 3 goes right here. -2 for the x direction, 3 for the y direction, and then 4, 5. 4, 5. Now, when you connect them, it should make sense that you're going up 1 over 3. If you want to put in more points for the up 1 over 3, you can do that. If you can count to 3, you can do it. It works. See that? Isn't that crazy? Do you like some remediation during flex? Can help you with that? Okay. I think you'll figure it out. I believe in you. I do. I believe in all of you. You just need to be quiet and listen to me. All right. We'll maybe just do one more of these because we're going to run out of time here. All right. So look, x1, y1, x2, y2. I really don't know why anyone's talking besides me. No one should be talking except me. If you don't want to label those, that's okay. And you're right. Let me get everybody else there. Or well, actually, no, I think it's the other way around. Hold on. Which ones are your y numbers? Good. So it's 5 minus 5 over, what's going to go in the denominator? 3 minus -1. Good job. Thank you. I'm going to share my screen and just type that in. So you need to know the formula, but then the calculator will do the rest for you. What was it? 3 minus -1. What's it come out to? 0. And so when you plot those 2 points, -1, 5 and 3, 5. Yeah, it's right here. -1, comma 5 and 3, comma 5. When you connect them, do you see how it's a 0 slope? Yeah, it should make sense. Everything in math should make sense. It's like nothing should be like a surprise. Go ahead. Couldn't you just plot the points and look at it? Yeah. 100%. All right, I'm going to skip this one because we did enough of those. All right. Now I'm going to show you how to do the same thing from a table. Guess what you need to do in order to understand this is listen to me and watch. Okay. So we're going to look at the y's first. I'm going to cover this up. Are you looking at the y number? I'm going to skip it so that we have enough time to finish. We did enough examples. We just need to do enough so that you understand what's going on. All right. Now listen and look. Look and listen. -20, -23, -26, -29. What's happening each time to get subtracting 3? It's difficult because they're all negative, but it is subtracting 3. Now I'm going to cover that up. We're going to look at the x's. -2, -1, 0, 1. What? You are adding 1. Okay. Now, all you have to do is remember it's y over x. That's the one thing that people mix it up, all right? So it's going to be -3 over 1. If you don't want to put over 1 and you just want to put -3, that's okay because the one, like when it's 1, it doesn't matter, but -3 over 1. Let's try it again. Hey guys, look at the y's. 3, 8, 13, 18. What's happening in the pattern? Up by 5. Good job. See, you can count to 5. Told you I believed in you. All right. Now, if I cover this up, 1, 4, 7, 10 is plus 3. So it's 5 over 3. Boom. Got that? All good? What's that? Yeah, that's the way numbers work. All right. And then we'll just do one of these. All right. Shh. Listen, we'll just do 16. I'll leave 17 because it seems like you guys got that. Shh. Are you listening? Do you guys know what an area code is? Do you know what our area code is in this area? That's a zip code. 804 is our area code. Hold on, I'm pausing the recording on this. So this says there were 285 area codes in 1999. There are 335 area codes in 2022. What happened to the number of area codes? Why do you think there are more now than there were before? More people, we need more phones, more telephone numbers. Whoever's doing that clicking needs to stop that. All right, so listen, you're going to write 2 coordinate points. So go ahead and you can just write them out blank. In 1999, there were 285. So it's 1999, comma, 285. What's the other point?
300 or 2022.
Two. Perfect. And then there were 335. Now, if you want to label, you can. If you don't, that's fine too. I'm not going to take off if you don't label. What's going to go in the numerator of our fraction? Use your formula.
335.
335, good. Minus 285 over 2022, 1999. Now, what am I going to do with that? Put it in the calculator. Don't stop listening to me until we finish this. Oh, actually, don't stop listening to me at all. There will always be subtraction. Can you guys listen back there? So 335 minus. Can you guys look and listen? And then what was it, 2022? All right, 50 23rds. Now listen, usually you'd want a fraction, but in this case, does 50 23rds make any sense when you're talking about area codes?
No.
Not really. So let's get a decimal. We'll say 2.17. Don't stop listening to me. 2.17. And when you are talking about slope, ladies, I'm going to have to alphabetize you guys. Do you guys want to get to sit with the people you chose your seats, or do you want me to have to alphabetize you? You need to be able to listen to me. When you talk about slope, you need the word per. It is something per something else. Now use your common sense. What do you think? No, something per something else. What do you think it's going to be for this problem?
Per year.
It's going to be what per year?
Amount.
What's the other thing in the problem? Area codes per year. Do you see how that's a positive number? It means the amount of area codes was going up. We have more now than we did before. And we added approximately 2 per year over that time span.